Hey everyone, Jacob here with waterwellfaq, and this video tutorial is part 2 of our submersible well pump sizing video. So if you'll remember back in part 1, that was all about calculating your total dynamic head, estimating what is the total head pressure in the system for our flow rate. So we'll do a little quick refresher on that. If you'll remember from our worksheet, we came up with 478 feet of head at 16 gallons per minute. So what we're going to do is we're going to take that information now and we're going to go to an online pump sizing application, put that information in, and find the best fit pump for our water well. So if you'll start off on our website at waterwellfaq.com, go to the resources section, scroll down to the Grundfos Product Center. I'm partial to Grundfos pumps. I think they make a really good pump. And I really like their online product center website. It's got some good information and it's got a really good pump selection software to use. But if you're partial to Berkeley pumps or Franklin pumps or Gould's pumps, you can take your information and go to any of their websites and sizes there, or you can use a product pump manual that has all the pump curves in it and use your flow rate and total dynamic head to size off of a curve that's published and printed in a manual. I like the websites because it's the most up-to-date information out there. Manuals don't get reprinted every year. Sometimes they go 3, 4, even 5 years between updates. And so for that reason, the stuff online is updated a lot more frequently. So I like to use the web-based sizing just for that reason. But you can definitely still use the old manuals, and that gets you really close as well. So we're going to click on this product selection link here to take us to Grundfos's website. First thing I want you to do is I want you to check right here, make sure this says US. If it does not, it'll say like www, or it may say something else, but just click this little globe icon right here and go over here and we're going to select our country and we're going to make sure we're on USA. And the reason for that is just to make sure that the search results that we get are specific to the USA, to the products that are available to us here and not international products overseas. So we'll scroll down here and we're going to go to size your product right here. So you'll have some options where it says size by. I like quick sizing. And then we're going to select pump design as select by. We'll click this little blue arrow here and scroll down. And here we're going to start inputting our information. So this is the information that we gathered from our worksheet. So we know our flow is 16 gallons per minute. And you can select here in different units, but gallons per minute. Our total dynamic head or head pressure here is 478 feet. You don't have to worry about the 0.32. If you want to round up or down, you can. Make sure you're set to feet here. Once we put that in, it's going to give us some more options. Number of pumps. We're just using one submersible pump. I don't select anything on mains voltage. That way it gives us options for everything, so we can see everything. And then on pump design, we're going to select submersible groundwater pump. Okay. Now, it's going to give you two options, groundwater supply or domestic water supply. I like choosing groundwater supply because it's going to give us a lot more options for different configurations. Domestic water supply is going to kind of narrow that field down. For this tutorial, we're going to leave it on groundwater supply. So once we got this all filled in, we're going to click Start Sizing. So as you can see here, it says it's giving us the 5 best matches. And what you'll notice is that they're all the same pump. They show all to be a 16S30-24. If you're not familiar with Grundfos's product names, their nomenclature for their pumps, we'll do a quick breakdown. The first numbers, however many digits it is before the S, that is the gallon per minute model series. So this is a 16 GPM series. It doesn't mean it's necessarily going to make 16 gallons a minute. That's just the average production rate at the highest efficiency for that series of pumps. The S is for submersible, and then the 30 is our horsepower code. It's not 30 horsepower, it's actually 3. So if this was 300, it would mean 30 horsepower. But this is 30, so that's going to be 3 horsepower. And then the -24 is how many stages. So it's 24 stages. So you'll wonder why there's so many different options for the same pump. And it really comes down to the type of motor you're going to use. The pump is going to be the same for any of these applications, any of these options here. But what we're focusing on here is voltage. So we got a couple different options on voltage. You can see they're all 3 horsepower. They all have the same flow rate. But we're going to scroll over a little bit, and we're going to see here under phase right here. So we got different phase, 3-phase or single phase options. And so what that's going to let us know is, are we using a traditional system where we just have single phase and a control box, or do we got 3-phase power? And we're going to use a 3-phase motor, which is a little bit more robust, can handle more starts per day, or we're going to use maybe even a VFD, a variable frequency drive. So whatever option you select, make sure you select the right one. Like I said, it's not going to change the pump or the pump performance, just it's going to change some information on the data sheets that we're going to generate later. So for our application, let's say we're going to do 208 to 230 volt, and we're going to do 3-phase because we want the option to do variable frequency drives. So we're going to click here. And it's going to take us to the product information page. So as you scroll down, it's going to default to your sizing results, and it's going to show you the curve. It's also going to show you where your design point falls on the curve. So up here in the corner, you can see that the closest it gets at full speed, this is a full speed curve, is 478 feet, and it's going to produce 16.5 gallons per minute. Now that's really close to our design point. So that's why it showed us the 5 best options were all the same pump, because this is definitely the best pump for our application. And another thing we're going to look at here that kind of confirms that is, where do we fall on this efficiency curve? This is the pump efficiency curve. The second line here is a pump and motor efficiency curve, as you can see down here. You can see that peak efficiency occurs somewhere around 15 gallons a minute, and it kind of starts tapering off after that. So we're peaking just under 60% efficient here, and it looks like we're peaking right about maybe 59. At our design point, we're at 58. So we're really close to peak efficiency. So that's a good sign that we are selecting the right pump. The other thing to consider is, where does your design point fall along this pump curve, this production curve here? Because we don't want to be too far right and we don't want to be too far left. If we're too far right, and let's say we have misestimated our total head, and it's less than what we think it is, well, that lower head is going to put us even further off the curve and may result in overpumping of our well, producing more water than what we can really sustain. And that would also create an upthrust condition in the motor, which could lead to premature failure in your pump and motor. Now, if we're too far left on the curve, then what can happen is, when we have, let's say again, we've not estimated our total head properly, and there's more head in the system than what we think. There's more total dynamic head. Well, as you can see here, if we're off by just a little bit, it can result in going from 6 gallons a minute at 655 feet, and just add 20 feet ahead, and we're going to lose about a gallon per minute. But it doesn't take much, and we're producing 3 or even 2 gallons per minute, just at 700 feet of head. So we don't want to be operating too far on the left. And that also shows you look at where your efficiency is. We're somewhere just above 40% efficiency over here at this far end of the curve. So it's not a good place to be. You want to be in the sweet spot of the curve that matches up with the highest efficiency. So we want to be in that 17 to 12 or 13 range on the low end, 17, maybe 18 on the max. But right now we're in a good sweet spot of this curve. So again, pay attention up here to your results in your sizing and your efficiency. Make sure you're in a good spot on the curve. And we'll scroll down. It shows you some information on your motor performance. So now you've got all this, and you said, well, this is at full speed. Well, what if I want to run it at a variable speed? What if I want to put a VFD on it? What does that look like? Well, we can generate and create a variable speed curve. So what we're going to do is we're going to go down here to show advanced options. Click that link there. It's going to pop up this window. I want you to select hydraulic layout. Right here under variable speed, select yes, select OK. The next thing you do is under curve types. Click the plus button, scroll down, curves for reduced speed. Let's click that. So here you're going to see some reduced speed curves at different percentages of full speed. All these other lines, we're going to turn those off real fast. That's your efficiency there. So we're going to turn that off. So now we can simplify this a little more and see it clearly. So now our information appears changed. Our design point is dialed in exactly, 16 gallons a minute, 478 feet ahead. That shows us we're going to run at 99% speed to do that. So we can see here it's added a new curve for 99%, but it's also showing us a 90, 80, 70, 60, and 50%. So full speed, 100% speed is 60 hertz. 30 hertz is 50% speed. And then 75% would be our 45 hertz range. So from there, you can kind of figure out where you're operating based on those numbers. So if you also wanted to see, well, what will this pump do at different flow rates? How will the speed change? Well, we have to adjust both the flow here and our head. So we can come back to our worksheet real quick. And let's say we want to know, well, what will this do at 8 gallons a minute? And at 8 gallons a minute, let's say we know our water level is now 280 because we're not pumping as much. So our pumping water level is a little higher. It doesn't pull down as far. So our new total head is 336.69. So let's round it to 337 at 8 gallons a minute. We'll go back here and we can put in 8 gallons a minute and 437. Enter. And then it shows us at 8 gallons a minute, 437 feet ahead, we're going to run at 83% speed. So now it's plotted the new spot at 83% speed, and it shows us we're well within that. We're still within this kind of sweet spot of the curve. We're not too far left, not too far right. We're right in the middle, and that's a good spot to be. And so we can see here and project what our pump is going to do at different flow rates, know what kind of speed to expect us to run at, and make sure that we have selected the right pump. So usually what I like to do is look at the max, the 16 gallons a minute, and then figure out what's maybe the low end. What's the lowest flow rate we might expect? Is it 8, 6, 5, 4? And just kind of see where our pump is going to be operating. If you see that you're ending up too far left, especially on your low speeds, you just need to make sure that your pressure tank is sized properly to account for that, because you may create some cycling there. Or maybe consider a different pump. But I think this is a really good pump for our application. It gives us a wide range of operating, and we're still at 80% speed, producing 8 gallons a minute. So we've still got plenty of bottom end. If we need to go a little lower. So let's go ahead and set this back real quick. 16 and 478. Another thing I wanted to point out is down here at the bottom, it shows you exactly how much horsepower is required by that pump for your design point. So we have a design point of 16 gallons a minute at 478 feet ahead. To do that, it requires 3.31 horsepower. Now, the dirty little secret, and most pump manufacturers don't want you to know about, is that even though they advertise a pump as a 3 horsepower, 2 horsepower, 5 horsepower, whatever it is, depending on your design point, that pump could actually require more horsepower than what its nameplate says. So its nameplate is 3 horsepower. With motors, submersible motors, we have a service factor. That service factor is generally 15%. You'll see it listed as 1.15 or 15%, meaning it can run at up to 15% overload and still be safe. So 3.31 gets us over full load, over our 3 horsepower full load. So we're pushing into that service factor range, but according to the manufacturer, we're still safe. We're still within the safe operating range. So we've got all this done, and we know that this is our pump. So what next? Well, now what we're going to do is we're going to save all this information. You can click here and see the drawings or see the specifications, but we're going to save all this into a PDF so that we can provide it to a client, keep it for our records, and like I said, just have another piece of deliverable information to kind of help set yourself apart, be a little bit more professional. So I'm going to go up here and I'm going to click on Print PDF. The first thing I'm going to do is I like to go to the page and header setup and go to Company Page Header, make sure it's checked, hit Edit. Put company name, created by, if you want to put your phone number, email, the date, all that good stuff. Click OK. You can even upload a logo if you want to put your logo in there. Next, I'm going to go back over to content, and I'm going to go through and check all the boxes I want. Some of these will be checked by default, so you can add or remove as you need. I like everything that's here so far, so I'm going to leave it as is. And so now that we've got all that, we're going to come down here. Let me move this out of the way. And we're going to click Generate PDF. So now it's going to generate a PDF for us. You can see we got 11 pages. Gives us our model information, product number, all the information about the pump, our design point, specifics about the motor type, electrical information. There's our service factor I was talking about. And scroll down a little further. You're going to see our pump curves. Here's our variable speed curve with our design point plotted. Motor curves, additional pump information. And so this is all good information that documents the design of the pump, your design point, dimensional drawings for your pump, some basic wiring diagrams, some estimated operational costs, things like that. So you can see kind of what to expect performance-wise out of this pump. A couple good drawings, some nice color drawings here for you to also show and depict, a little bit about what the system's going to look like. So now that we've got all this, we can come up here and we can go to download it, save it, name it whatever you like, and then print it. And then you have this to give to a customer, give to an engineer, or whoever you need to give it to. So that concludes our pump sizing video. As you can see, got a lot of good options. It's actually not that difficult. Once you have your total dynamic head and your flow rate, in a matter of minutes, you can have sized the perfect pump and generated a nice PDF with a bunch of information in it. Generate variable speed curves or just a basic simple curve, and have this information for you guys. So that way you know that you've sized and selected the best pump. So again, I hope you enjoyed this video. Please like and subscribe to our YouTube channel. Click the bell icon on our channel so you get notifications whenever we upload new content. Make sure to check out our website and subscribe to our blog to get updates on when we post new blogs. There's a lot of good technical information on there, product reviews, quick tips, tricks, tools of the trade, all kinds of good categories and resources for you to use, refer back to anytime you need them. Constantly updating that, providing new information. So I hope you guys enjoyed this, found this beneficial. Feel free to drop us a line at waterwellfaq@gmail.com if you've got any questions or there's any content you'd like to see from us in the future. Thank you.